Good morning, everyone, and this is the L-1 day countdown status briefing for STS-110. Here to bring us the status this morning is Pete Nikolenko, NASA Test Director.
Good morning.
Ben Jimenea, the STS-110 Payload Mission Manager, and Kathy Winters, the Shuttle Weather Officer. And we'll begin first with the launch vehicle status out of the pad and Pete Nikolenko. Pete?
Thank you, George. Good morning. I'm pleased to be here to provide countdown status for the launch of the Shuttle Atlantis to the International Space Station for our next assembly mission. The countdown is continuing in progress. Yesterday we completed the checkout of our onboard avionics systems, and we also completed a couple of non-standard tasks which required special protective ensemble. Solid rocket booster, hydraulic power unit exhaust duct plug removal, and also a oxidizer return line repair on the fixed service structure. Earlier today, we completed the servicing of our onboard fuel cell cryo storage tanks, which was delayed somewhat for the completion of those escape tasks yesterday. We're currently back at the pad, and we continue with main engine systems checks and pad closeouts, and we expect to catch back up on the timeline by later today. Our remaining standard countdown activities include the power up and checkout of our ground communications network, the retraction of the rotating service structure, and the ET cryogenic load. Following ET load, we'll continue preparations for flight crew arrival to the pad, which is planned for later on Thursday. Our launch period Thursday is 4 hours in length and extends from 2 p.m. to 6 p.m. with the actual launch time occurring within that window. And this is an 11-day mission with end-of-mission landing planned here at KSC on Monday, April 15th. In summary, all our flight and ground systems are looking great, our team's ready, and looking forward to Thursday's launch back to the space station. That's it.
All right, thank you, Pete. And now for the payload status, Ben Jimenea.
Thank you, George. Thank you, Pete. For the mid-deck payloads, yesterday we installed our biotechnology refrigerator, our BTR, and conducted an interface verification test on that, and that was successful. Today, this evening actually, on second shift, we will be installing additional mid-deck payloads, the CGBA, the CPCG, the ZCG, the PCG, and the BPS. All of these are normal installations, late stow installations, and as I mentioned, we will be conducting those this evening. For the primary payload in the payload bay, as you know, it flies unpowered, and there is nothing new to report there. It is, as far as I know, still in the payload bay.
All right, Ben, thank you. And for the weather now, Kathy Winters, Shuttle Weather Officer.
Morning. Currently over Florida, we do, looking at the satellite picture, we do have a area of thunderstorms. It's moving through just north of the central part of Florida, and those are going to be moving across the state and actually affecting our area today. We expect thunderstorms on and off throughout the afternoon and into the evening. We also think that we could get a chance of small hail with these thunderstorms. This could be a concern for any pad operations going on this evening. Looking for our tanking forecast, the front that was moving into Florida tomorrow is going to be stalling into Central Florida area. In the morning, it should be in the north part of Florida, though. So for the tanking forecast, we just have a slight chance of showers, but nothing that should prevent tanking. For our launch forecast, we do expect to get a sea breeze, and with a lot of moisture in the area with that front, we expect to get some showers and also a chance for thunderstorms. So we are looking at a probability of 40% for violating our weather launch commit criterion. And then for the recovery for the solid rocket boosters, we are looking at just isolated showers in the area, but seas only 4 to 5 feet. For the Kona sites, we are looking at good weather, nothing that should impact us at this time. And for the TAL sites for launch day, everything is looking good as well. For a 24-hour delay, we do think that front will slide to the south and be in South Florida, so our chance for showers are less. We look to only have a 20% chance of violating our launch constraints. And for the Kona sites, there is a concern at Edwards Air Force Base with crosswinds. And then for the TAL sites, we are looking also at some concerns at Zaragoza with the chance of rain, and also at Marone with a low ceiling, low cloud ceiling, and also a chance for showers as well. And then if there is a 48-hour delay, we are concerned just about a low cloud ceiling, also for some isolated coastal showers, and there's a crosswind concern as well, so we're going with a 40% probability of violating our weather launch constraints. If there's a 48-hour delay, the CONUS sites are looking red at white sands due to a crosswind. And also the TAL sites not looking good either, looking for some showers at both Zaragoza and Marone, and some low cloud ceilings at Marone and Ben Greer. And this concludes my briefing.
All right, Kathy, thank you. And now before we take questions, we have some video of the STS-110 payload, which will be discussed for us by Ben Jimenez. Ben?
Okay, thank you, George. This scene here is the Super Guppy arriving at the shuttle landing facility, delivering our payload. That was back in January of 1999. Interesting vehicle, the Super Guppy. We put it on the trailer, and we will be towing it into the operations and checkout building. Removal of the transportation cover. We'll install a strongback, lift it, and transport it over into test stand 2. In the next video or next scene, test stand 2 is the far test stand. Installation of S0 still wrapped in test stand 2. This is further along in processing, near towards the end, possibly last month. I can tell that because of all the shrouds. These are the crew members looking at the mobile transporter, the port end of the truss. One of our crew members, I believe that's Lee Morin, looking at some shrouds. Jerry Ross. And again, another scene for the port end of the truss. This is our lifting of the truss out of test stand 2, getting it ready, putting it into the canister. This is S0 and the mobile transporter in a full flight configuration. We're installing it into the canister. After installation in the canister, we rotated the canister into the vertical orientation and brought it out to the pad. We brought it out to the pad on March 23rd of this year. There it is being installed into the payload changeout room, the PCR. Impressive sight, the orbiter and the shuttle stack. These are the canister doors being opened. S0 and the mobile transporter will be installed into the PIGM. You'll notice it's a rather large payload. Photo of the ODS, Orbiter Docking System. I believe those are some of our crew members. And a photo, I believe, of S0 in the payload bay as the doors are closing, and that was this past Monday, April 1st. Next opportunity to see S0 will be on orbit when the payload bay doors open.
Thank you, Ben. We're ready now to take questions. Please give your name and affiliation when the microphone comes to you. We'll start here in the front with Steve.
Steve Stanislaw, Florida today. I have a couple of quick ones for Pete regarding the external tank doors. Was there any great push forward overnight that makes you all pretty comfortable with those, or are you still awaiting a final decision?
And we're still awaiting results from the analysis, and that'll be discussed at the management meeting later this afternoon.
Is there any way to test, I doubt that there is, but is there any way to test Atlantis's doors, or are you strictly looking over paperwork from previous?
It's B. We're looking at what we've already performed previously in the orbit processing facility, and there's no rework or testing we can do at the pad.
Steve.
Stephen Young with spaceflightnow.com for Pete. I'm just wondering if the severe weather that Kathy's forecasting for later today will affect any specific operations, or whether you feel you can get through that okay.
We're going to watch it closely, obviously, but we don't expect it to delay our pad closeouts or any of our remaining countdown activities now.
Any further questions? All right, in that event, that concludes our briefing. Thank you.
Good afternoon and welcome to our STS-110 launch delay press conference. We have sitting with us Mike Leinbach, Shuttle Launch Director. And Mike will have a opening statement and then we'll take questions after that. Mike?
Okay, Bruce, thanks. Well, as you all are aware, we did have to scrub today's launch attempt of STS-110, Atlantis' trip to the International Space Station, delivering the S0 truss. I'll walk you through a brief sequence of events that we went through in the control room this morning. And then we'll show the video. I think that'd be a good way to intro it, and then we'll be glad to answer any questions. We got into our external tank cryogenic loading essentially right on time, about 5 minutes after 8 this morning. And the first phase of that loading technique for both the oxygen and the hydrogen is a chill down sequence where we do a very, very slow release of the liquid through the line. It gases off and chills down the line so we don't cryogenically shock those lines when we introduce the liquid. After the chill down, and that's about a 20-minute or so process, after the chill down we go into our slow fill technique, which is more thermal conditioning of the lines, and now we're actually flowing liquid to the lines up to the vehicle. Once we go through that slow fill for a period of time and all the seals have done their thing and we're sure that we don't have any leaks, etc., we go into our fast fill. It was during the fast fill on the hydrogen side that a facility vent line leaked. This was on the side of the mobile launcher. It's a pipe external to the mobile launcher. All the leaking gaseous hydrogen was vented to atmosphere. There was no problem with the vehicle itself. The vehicle was very, very tight, no issues there. There were no leaks inside the mobile launcher. The leak that you will see on the video is completely exterior to the mobile launcher. So we picked up that leak on a visual from our guys in the control room. We do a scan of the whole vehicle and the MLP in the facility as we're loading. We do that every time, and during that visual scan, our engineer did see the leak, and we zoomed in on it, secured the fast fill on hydrogen very quickly. About a minute after we spotted the leak, we terminated flow on hydrogen, and we talked about the situation for another 12 or 13 minutes or so while we continued to load oxygen, but determined very quickly that the leak was way out of spec and we were going to have no launch attempt today, and at 9:27 this morning declared a scrub of STS-110. And with that, Bruce, that might be a good time to show our issue.
Okay, let's play that tape.
This is a view from east of the pad, northeast of the pad. You can begin to see the vapor there on the east side of the mobile launch platform, sort of in line with the SRB, but of course it's on the side of the mobile launcher. There's our leak. Again, this is a facility vent line, a low pressure vent line. There's no liquid in that line at all. And what we suspect happened is that we had a circumferential weld at that joint, at that location, that for reasons not yet understood, fully decided to leak on us. More than likely cryogenic shock of some type. That is a cold line, but it is not at the full cryogenic temperatures because it is a vent line. So again, once we terminated the fast fill, the leak went away very quickly, although that was it for the day.
Okay, well, let's take some questions. Let's start down here. Marcia.
Associated Press. Mike, was there any danger posed by all this fuel vapor seeping out into the air?
Well, no, not really. That's why I wanted to make the point very clearly that it did vent to the atmosphere. This was a fairly high concentration of hydrogen gas, to be sure. We don't have a leak detector at that location. We don't have leak detectors at every welded joint in the system. We couldn't physically do that. And in situations like this where it's venting to the atmosphere, we don't feel like we need a leak detector. So I can't give you a concentration, although it was a fairly healthy leak.
Wondering if static electricity could have ignited it, for instance.
Very, very unlikely at that location because it is vented to atmosphere, and you have to have greater than 4% in air of hydrogen to get any sort of burn potential, I guess you'd say.
Bill, what about there?
Bill Harwood, two quick ones for me. I guess you guys are looking at 3 options perhaps to get going. Could you review what the repair scenarios might be and what that does to potential launch dates?
Sure.
I don't realize you're going to make decisions, but just what's the range of things you're looking at?
Yeah, understand we're just now getting folks out to the launch pad. We're gonna get an engineer and a technician and a safety guy up in a high ranger and get right up to this line once we verify that it has been fully inerted, and that should be very shortly from now, very soon from now. So once we do go inspect this weld, we will pick the repair technique that we want to go after. Right now we're looking at 3 different techniques. The first one would be to grind out the suspect weld and re-weld in place. Just put a new weld there. The second one would be a clamshell type of affair where we would put like another pipe around that pipe and weld the ends of that pipe onto the existing pipe, if that makes sense, or sleeve it, sort of, and weld those 2 ends. Third option would be we would have to remove, this third option is only if we don't have enough access around that pipe to do the full weld job. Then we would have to look at taking that pipe off the side of the mobile launcher, lowering it down to the pad surface and welding on the pad surface and then reinstalling.
What does that do to your launch options?
Right now what we've told the team and what we're going after is we're no earlier than Sunday morning, or Sunday afternoon, I believe. So we're into a 72-hour scrub turnaround at this point. And once we get that information from the pad with the engineers, this afternoon we have another tag up and we will refine that plan. But right now we're no earlier than Sunday.
That was just my first question. My second question was to follow Marcia. You mentioned 4%. Would you expand on that a little bit? I remember back on 41D, I guess, when you guys launched Discovery the first time and had an RSLS abort, you had some hydrogen gas that started burning and invisibly. What's the contaminant level that you have to make a burn hazard, just to help us put that in perspective?
Well, it has to be 4% hydrogen mixture in air to create the combustible environment. So if we were at 4% there, I'm not prepared to tell you.
Okay, Mike.
Mike Cabbage with the Orlando Sentinel. Could you characterize what you know about the size of the rupture at this point?
Well, again, until we get the guys out there looking at it, I mean, you saw the video, the same I did. It looks to be probably 3/4 of the way around that pipe. So it was the way these welds. This is an aluminum pipe, an aluminum weld, and joining 2 sections together. And when you have a cryogenic weld, cryogenic failure of a weld, typically the crack will grow around the circumference, much as we saw here. It's called tea kettling. So that's what we expect happened. But we'll go inspect it and make sure that that's what it was.
And what's the diameter of that pipe?
It's a 16-inch outside diameter pipe. It's actually a double wall pipe in the vent system. So the pipe that you see on the video leaking, that's 16-inch diameter.
Mark?
Mark Carreau from the Houston Chronicle. what's the possibility that this incident would cause you to inspect all the plumbing, all the welds, or are you comfortable that this is isolated because of prior operations?
What you said at the last is the right answer. I mean, you know, this mobile launcher has gone through 80-some tankings and has performed perfectly fine. So we do not feel we have a generic problem with all of our welds out there at all. This guy just happened to react today.
And certainly there's been some attention in the last couple of years about infrastructure needs at KSC and various facilities that you use for the shuttle. Any way that this is anything that comes into that arena, or do you feel that even though this is Apollo era stuff originally, these kinds of fittings are new, or can you just give any context to that?
Well, this mobile launcher was retrofitted after Apollo, so these lines have been in place since those days for the shuttle program, and this is an original weld, the way I understand it. We're going back through all of our problem reporting paper and verifying that this particular joint has not had a problem in the past. We don't believe it has, but we're going to go back and look through our paper system to make sure it hasn't. This is not unusual in a system like this to have a weld fail. It doesn't happen very often, but it shouldn't be totally unexpected either.
Okay, let's go to Warren. I believe you had a question.
If these 3 fixes you went through don't work or aren't practical, what's the possibility of rolling back and doing something a little bit more?
We're going to get it with one of these fixes. We're not even thinking of anything other than fixing what we have out there.
Stephen?
Steve Seislaw from Florida Today. Mike, I'm wondering if you can characterize or clarify for me the risk posed to the shuttle when this leak was occurring. I mean, if there was an ignition, would it just flash momentarily, or what's the scenarios there?
Well, again, this is on the east side of the mobile launcher, about halfway up the total height of the mobile launcher, which is about 25 feet thick, I guess you could say, well away from the orbiter. Again, we had no issues with the orbiter or the piping through the mobile launcher. This was exterior, and we didn't ever consider this a threat to the vehicle. And of course, during external tank load, there is no one at the pad, so there was never any safety issue with people at all. And just really don't feel it was an issue. We saw the leak and terminated the flow per our procedures, and we're going to recover from it.
Okay, Bill?
Coach on Earth News. I was surprised when you said this is a double wall pipe, so that would have to imply that both walls broke to some degree, or that you had a leakage between the inner and the outer walls, or something like that.
This is a double wall pipe. The design of this double wall pipe, given that it's a vent system and not a fill system, there's a tremendous difference between a vent system and a cryogenic filling system. On the fill systems where we have liquid going through the pipe, remember this pipe never has liquid in it. On the fill systems we have a vacuum jacketed pipe, and the vacuum creates the insulation between the fluid in the inner pipe and the atmosphere against the outer pipe. In the vent system at this location, it's a double wall pipe, but there's communication of the gas from the inner pipe to the outer pipe. By design, there are slots in the inner pipe that allow the gas to get in the annulus space between the inner and outer pipe, and then that gas provides an insulation blanket to the gas that's on the inner pipe. The purpose of that is to keep the outer pipe as warm as we can, so we don't form liquid air on the outer pipe. So this is by design. There is very definitely by design gas on the inside surface of the outer pipe, no question.
And is there any way to estimate or swag, given the amount of time the pipe was open and normal flow rates for the vent, just how much hydrogen was expelled, cubic feet or pounds?
I don't know. It wasn't that much.
Stephen?
Stephen Young with SpaceflightNow.com. Could you give us some idea of what the purpose of the vent valve is? Where does it actually vent from, and where does it go, and what purpose does it serve during the countdown?
Sure. We have 2 ways to vent hydrogen from the vehicle and from the facility. One is out the external tank vent line that you see disconnect right at T0 off the side of the external tank. That's the way we vent hydrogen out of the tank itself. And that goes through a separate piping system out to our flare stack, which is east of the pad, and that goes up the flare stack, and we burn off that hydrogen gas out that flare stack. This is another vent path. We need redundancy in case we have one issue with one vent line. We have a separate vent system to vent the vehicle, and it does the same purpose. It's just a different route for the gas to go. It ends up in the vents in the flare stack, just like the other vent does, and we burn it off to atmosphere.
And when this event happened, it seemed like several times the vapor died away as though the flow had stopped, and then it erupted again. Was that part of your testing, or was that just that you needed to vent through that line to keep your pressures at the right levels?
No, once we terminated flow, we had shut off the valves to the vehicle, and it just took a period of time to vent down. I didn't see a heck of a lot of pulsing. That was not part of any troubleshooting. We stopped flow, valved it off, and it just bled away.
Thank you, Jim. Jim Banky, Space.com. Mike, are you already convinced then that it was cryogenic shock that made the weld give way, or do you need to do some kind of troubleshooting failure analysis before you're ready to do the tank again?
We're real certain it was cryo to some extent, especially once we got into the fast fill. Then that vent line was venting more gas, so it got colder at that time. We're going to go look at support structure in that area to make sure that things were moving as they're designed to. These lines, by their very nature, have to expand and contract, and so we have different setups along the line to allow these lines to move somewhat. It's not a heck of a lot, but they do move. So we'll go look at that and make sure they weren't compromised in any way. But you can pretty well bet it's going to be a cryo shock issue.
And just to clarify on your options, if you took the pipe down and put it on the pad, would that automatically mean grinding out the weld and re-welding it, or is the clamshell still a consideration?
The reason we would take the pipe down is because we couldn't do either of those weld repairs with the pipe installed because we didn't have good enough access to do the welding. So at that point, once we had the pipe on the ground, it would be engineering call to tell us which way they wanted to go. Either one would work at that point.
Okay, let's take it down the aisle here.
Mike, what's the temp? Any idea of the temperature that you were talking about? You said it wasn't real super cool, but what exactly would the temperatures have been that would have caused that cryo shock?
I don't have that exact temperature for you. I'd have to go get that for you. I'm sorry.
Okay, right there.
Irene Brown, QPI. Will the crew stay in Florida, turn the repairs, or go back to Houston?
I don't know. We'll have to. I've been concentrating so much on the pipe. I don't know what they're planning on. Do you know?
We'll find out for you. Right now. Brad?
Brad Liston from Reuters. Given that this was a vent pipe rather than a fill, are you surprised that you would see cryogenic shock there rather than in a fill pipe first?
Well, the temperature is certainly not as cold as the liquid. I mean, I can tell you that definitively. What the temperature is, I don't know. We're going to have to go look at this weld and see what first started the failure at this weld. There may be a smoking gun there that we can go point at and learn the definitive reason it started to leak. And we'll just have to get back to you on the details. Again, the guys are out there right now looking at it. So.
Okay, let's go back to Dan, then we'll bring the mic back around to you, Peter.
Dan Billow with West TV. Question and a follow-up, if I may. Mike, you say you never considered it a threat to the vehicle or a threat at all. What is the threat then, if you could help me understand? What's wrong with having hydrogen leak out of the pipe like that?
Well, it's a violation of one of our basic ground safety tenets is that we need to contain all hydrogen. Any gaseous hydrogen we don't want, we put up the flare stack and we burn off in a very controlled fashion. We were not going to continue with a leak of this magnitude on the vent line or any other line. It just didn't make sense to continue.
And are you comfortable with the fact that your backup here? What saves you in this case is just looking at this visually, and there are dozens and dozens of welds and being able to get an eyeball or a camera on every one of them. Is that sufficient? Does that make you comfortable?
Absolutely. It worked perfectly fine. That is our procedure.
Okay, Warren, let's take Warren right here before we move to the other side of the room.
Warren Leary, New York Times again. You didn't know the temperature of the gas in that pipe. Do you have any idea what the normal pressure would be?
It's a vent system that probably doesn't see any more than about 20 psi.
And in terms of the weld itself, when the pipe pulled back, doesn't that put some pressure on other welds? Will you have to x-ray those welds in some way other than to do a visual inspection to make sure the adjacent welds are holding?
As I say, we have not indicted all the other welds on the mobile launcher. That is not part of this issue at all. This was a single failure of one weld. While we're out there, we're going to go look at surrounding structure and surrounding pipes and just do a common sense look around the area and see if there's something else out there. But we are not right now planning on doing a complete system walk down and complete weld inspection per weld. It's not warranted. Either way, we're not planning on looking at every weld out there. Again, they've survived 82, I believe the number is, tankings, and this one decided to be a problem for us.
All right, Peter? Peter King, CBS News Radio. Mike, I know you don't know the exact temperature. Any way you can give us even a range of what might be normal?
Can I get back to you? I really don't.
And just to verify one thing, did you say that the pipe is made out of aluminum?
That's affirmative.
Okay, let's go all the way to the back, and then we'll take a few more questions.
Tony Winton, Associated Press Radio. Could you just explain in layman's terms the term cryo shock? Is it something really cold causing something to brittle up? Am I understanding that right?
Essentially, cryogenic temperatures when they get on aluminum like this tend to shrink the aluminum. It's a physical phenomenon that happens to all metals. So we call it cryo shock. It's again, as I described early on, we go through a very methodical process up front in the loading sequence to chill the system down very slowly, so we don't truly shock the system. We would never go straight into fast fill from the start. That would be a cryo shock per se. So it's a thermal phenomenon on the metal itself that tends to shrink the metal slightly.
Mark?
Mark Carruth from Houston Chronicle. I guess I got lost at one point in something you said, so I'm looking for clarification. But what it was when you went to the fast fill, after that point you started to see evidence of the leak. Do you know about how long it leaked from your visual monitoring, and what action did you take to stop it? Was it closing a valve? I'm sorry, I just got lost somewhere in the sequence.
Yeah, we saw the leak at 9:11, and the system was secured at 9:12. So we reacted as our procedures tell us to, and stopped flow. We shut valves at the storage sphere, and that shuts off the flow to the vehicle. And we go into a drain scenario after that to get the liquid off the vehicle, because we did have some on the vehicle at that time, but very, very little.
Mike?
Mike Cabbage with the Orlando Sentinel. Can you quantify how much of the hydrogen tanking had been completed at the time the leak happened?
Well, let's see. We were started at 8:05 and we secured at 9:12. It's a 3-hour process to fully fuel the shuttle. So we were roughly 1/3 of the way through, but we had just gotten into the phase of the loading where the flow rate increases to our fast fill. So we were one third of the way through the timeline, but I'd say we were probably no more than 10% fill in the tank, say.
And is it possible to quantify in any way how much hydrogen leaked?
No, we'll have to go back and look at the tapes and try to do that, but that's not our focus right now. Our focus is to go out there, understand what happened, and fix it, and get to our next attempt.
Marcia Den, Associated Press. Is it possible that it was actually leaking before it was seen by the engineer? In other words, was he staring at the camera with that view and then noticed it, or was he doing something else and then came back? Or?
No, he saw it right when the leak began. He was monitoring his monitors. He has several monitors in front of him on that console, and they all go through a preset scenario of what they're looking at. And there's more than one engineer. Which particular engineer caught it, I'll have to go find out and thank him. but it was very, very quick, I can assure you.
Idea how old that weld is? Is the weld itself also original to the piping, or
Yes,
might it have?
it was original. Yes, it was part of the original build for the shuttle use of this mobile launch platform.
Okay, let's just take a couple more questions. Bill, one more.
Phil Chen, obvious question. Any idea what the first launch was off of this platform for the shuttle program?
Phil, I was going to ask you that.
Okay. Easier one. With 72-hour turnarounds, any chance to get into the mid-body and top off the PRSDs so you have a full launch?
Yeah, absolutely. In fact, that is our plan. What I've told the shuttle program is that I would take the 72 hours. We need the 72 hours to effect this repair. We could not do this repair in anything less than 72. But the 72-hour scrub turnaround affords us the opportunity to top off PRSD, just as you say. We'll go in and top off both the LOX and the hydrogen for our fuel cell system and get us back into essentially what we're calling a first launch attempt posture on Sunday.
All right, right here.
Dave Santucci with CNN. Do these pipes have a scheduled retirement date, and what is that? I mean, you know, the shuttle's only supposed to go up about 100 missions. Are these only supposed to be used for 100 tankings?
No.
There's no scheduled retirement date?
No, when you put a system like this together, you expect that it'll last for quite some time, and these are not exotic pieces of piping. I mean, this is aluminum pipe that we weld together. That part of this system is not rocket science.
All right, so the PTV. Mine is a countdown question. Obviously, this has been a very secretive countdown up until last night. I know we don't have a set launch date yet, but can we assume that process will repeat itself sometime over the weekend?
It will. In fact, the plan right now is that our launch period is going to be between the hours of 2 and 6 p.m. for any time after today. It's the same, between 2 and 6 p.m. Other questions before we wrap it up here? Brad, one more.
Brad Listen, Reuters. Mike, I'm sorry, I'm going to have to ask you to repeat something. I thought I understood earlier that you said that this weld dated back to Project Apollo, but was it part of the retrofit for the shuttle, or does it date back that far?
Well, I believe it was part of the retrofit for the shuttle program. Again, in the meeting I had a couple hours ago, we didn't get into that level of detail because we were more concerned about fixing what we have out there. I'll have to go off and find out if this is a Shuttle or Apollo vintage weld.
Okay, and Peter, I'll let you ask the last question.
Okay, and that's a follow-up to yours. Peter King, CBS News Radio. Was that dated back to what, 1977, 78, 79?
This was Mobile Launcher 3, came online, I believe, shortly after mid-80s, I believe. I'll have to get those dates for you. Or you could ask Phil.
Okay. And with any additional information that we come up with over the next day or so, we'll put that out in a written status report. Thank you very much.
And it is time now for a look at the U.S. weather forecast. For that, we go to Femi Oke, who's in the Weather Center. Femi?
Hello there, Colleen. You were saying earlier how a hydrogen link had actually delayed the shuttle link. You can go on with the rest of your work, Colleen. I know she was dying to read the rest of her show. But this is a beautiful day across here, Cape Canaveral in Florida. So the weather looked like it may just have been able to play ball. This is a live shot from NASA TV. Thank you very much, NASA TV. You can see a little bit of fair cumulus cloud just around, some blue skies there. But it's really how much cloud you have as to whether this would go up, and also thunderstorms and showers in the region. Let's get rid of NASA TV and have a look back at our satellite picture. It was smoothly done. I want to head down here and see if there are any thunderstorms or showers on our radar somewhere. And little bits of green here, but a lot of this wet weather now clearing up quite nicely. There was, you may remember from yesterday, a big weather front pushing towards the east, and now we've lost an awful lot of that wet weather. So it looks like, even though the shuttle's not going to get off today, tomorrow should actually be a good weather day for it, clouds allowing.
Sie sollte am Morgen von Cape Canaveral ins All abheben. Beim Auftanken war jedoch ein Leck in einer Wasserstoffleitung entdeckt worden. Die Atlantis wird sich nun voraussichtlich am Sonntag auf den Weg zur Raumstation ISS machen.
Yesterday, last night when I was talking to you, how I think it's cracked. Yeah, we're going to discolorate. Possibly already there. It's got circular pattern there. The only boogered it a little bit, right. You know, good. Okay.
Good morning and welcome to our STS-110 launch minus 1 day countdown status briefing. We have with us this morning Pete Nikolenko, the NASA test director.
Good morning.
Ben Jimenea, the STS-110 payload manager.
Good morning.
And Kathy Winters, our shuttle weather officer.
Good morning.
And we'll begin our briefing today with statements from each of these, beginning with Pete.
Thank you, Bruce. Good morning. I'm pleased to be here today to provide scrub turnaround and launch countdown status for the launch of STS-110 to the International Space Station. As you're aware, we scrubbed our launch attempt Thursday due to a significant gaseous hydrogen leak on a facility vent line on the east side of the mobile launcher during our LH2 cryogenic load. Once our scrub was declared, we performed our standard securing operations, including external tank drain and inert gas purging. We then sent some engineering and technical experts up to inspect the vent line Thursday afternoon. They determined that a weld failure had occurred around most of the line. Following some engineering meetings, it was decided that a permanent clamshell repair would be performed. This clamshell repair essentially consists of two 10-inch wide sections of pipe installed over and welded around the failed line weld. This action was successfully performed late Friday and into Saturday. Yesterday, the repaired line was certified and retested per design requirements, including dye penetrant inspections, a cold shock of the line using liquid nitrogen, and various pressure leak and decay tests. All those tests and leak checks were successful, and we're confident that we have a good vent line. While that activity was in work, we've also been performing our standard scrub turnaround inspections of the pad and are currently finishing up with the top-off of the fuel cell cryo storage tanks. Later today and tonight, we will continue pad closeouts and get back into counting down, which includes our remaining standard countdown activities such as power up and checkout of our ground communications network, retraction of the rotating service structure, and ET cryogenic load. Following ET load, we'll continue preparation for the flight crew arrival to the pad later on Monday. The launch period for Monday, April 8th is 4 hours in length and extends from 2 p.m. to 6 p.m. Eastern, with our actual launch time occurring within that window. This is an 11-day mission with now end-of-mission landing planned here at KSC on Friday, April 19th. Based on our PRSD top-off this morning, we do have 24 and 48-hour scrub turnaround options available to us, which will still give us 4 launch attempts in 5 days. In summary, all our flight and ground systems are now looking good, and our team is ready to support launch on Monday. Thank you.
Okay, and I believe we had a tape that we'd like to roll at this time of the work that was done.
Okay, this is a shot looking at the east side of the mobile launcher with the High Ranger in place. A little close-up shot, and it'll zoom in just a moment, essentially showing you this 10-inch wide clamshell repair that's now highlighted. We had personnel up in about 3 personnel up in a bucket that was on a High Ranger extending up from the east pad surface to perform the weld repair.
Okay, thank you very much. And now Ben with our an update on our payloads.
Thank you, Bruce, and good morning, everyone. After Thursday's postponement of the launch, our mid-deck organization had a conference with our experimenters and decided that 3 of the mid-deck experiments would be removed and reworked and get ready for launch on either Sunday or Monday. Those items that were removed were the CPCG-H, the PCG, and the BPS. The 2 items that remained, or the 2 mid-decks that remained, were the CGBA and the ZCG. For those 2 items that remained, the experimenters sent us a letter allowing us to keep those experiments in the mid-deck. The 3 that were removed will be reinstalled this evening in preparation for launch tomorrow. And once those mid-decks are installed, we will be back to a nominal mid-deck configuration and ready to support the launch.
Okay, Ben, thank you very much. And now an update on our weather. Kathy Winters.
Thank you, Bruce. Well, Kennedy Space Center is getting a break now from the thunderstorm activity that we were seeing last week at the end of last week. But now our new concern for launch is the strong winds that we're going to be getting at the pad tomorrow and at the shuttle landing facility tomorrow. If we look at the satellite picture, currently we just have scattered skies over Florida. There is high pressure that's off the coast of the eastern United States. And we're expecting low pressure to move into Texas tomorrow, creating a strong pressure gradient over Florida, which is going to increase our wind speeds for tomorrow. Moving into the tanking forecast, we are just expecting scattered skies, gusty winds, but no, we're expecting just 0% chance of violating tanking constraints. For launch, again, just scattered skies, but we do have those gusty winds. Winds are going to be 22 knots peaking to 30, and we have a 40% chance of 40% probability of KSC weather prohibiting launch. For the SRB recovery, they're also expecting some strong winds with peak winds up to 26 knots, and seas are 8 to 9 feet with those strong winds. And for our launch CONUS sites and TAL sites, the CONUS sites are done by Carl Silverman at SMG. All of those sites look good, both at White Sands and at Edwards. And for the TAL sites, everything's also looking good for launch day as well. And the TAL sites are done by Richard LaFosse at SMG. For a 24-hour forecast, we're looking at scattered skies for our area. Winds are still gusty, but not as strong as they are going to be on Monday, and just a 20% chance of violating launch constraints. The CONUS sites are all looking good. There are some concerns at the TAL sites. Chance of, okay, they are showing up a chance of a low cloud ceiling at Zaragoza, and also a slight chance for rain showers within 20 nautical miles at Marone. If we do happen to go into a 48-hour delay, we are looking good still, similar weather as to Tuesday, and just a 20% chance of violating our for KSC to prohibit launch. And the 48-hour CONUS sites, weather is looking good. This chart is showing good, but actually I think we do have some crosswind concerns at Edwards and also at White Sands. And for the TALs, we are concerned, very concerned about TAL sites on this day, looking at low cloud ceilings at all 3 sites, rain showers at Marone on station. Zaragoza and Ben Greer both have showers within 20 nautical miles, and also a crosswind concern at Ben Greer with winds peaking up to 26 knots there. So in conclusion, day 1, the main concern for launch day is the winds at KSC. For day 2, we're looking better at KSC. Just slight concerns at the TAL sites for some showers and low ceilings. And on day 3, our primary concern is the TAL sites. And this concludes my briefing.
Okay, Kathy, thank you very much. And let's take some questions. Let's start with Steve right here.
Steve Stice, Florida today. My first question is for Pete, and that is, over the course between Thursday and now, have you had a chance to test all of the MOP lines, or did Thursday's tanking pretty much clarify all the lines you'll need except for that one weld, and you just focused on that one weld during time?
We primarily focused on that one well, but we did do leak checks of all the external lines from the MLP out to the facility flare stack. So we're comfortable that and confident that that our ground lines are good.
Thanks. And also, how about the shuttle itself? Did you get a chance to do much testing on that, or during that first hour of tanking?
Well, during a standard cryogenic load operation, our focus is in just monitoring the orbiter systems while we perform the load of the tank. So there wasn't really any testing in progress at the time of the load.
Okay, let's go to Brad right here.
Brad Listen from Reuters for Kathy. I think on the 24-hour and 48-hour turnarounds, the graphics were showing 20% no-go for tanking, but that is for launch, right?
That's correct. That's for launch. Tanking is 0% for all 3 days.
Okay, and Mark?
Mark Carruth from Houston Chronicle. I had two. One for Kathy Winter. Are the winds crosswind concern, or is that a different?
We actually have a little bit more of a headwind concern on that day. The winds are turning to be a little bit more southeasterly, and so we're getting close to our threshold for headwinds. We have not violated it according to the forecast at the shuttle landing facility, which our winds we haven't violated for the forecast, but we are close, so that's why we're going with the 40%. We do have pad constraints, but we're not going to reach those, we don't think, either.
The wind concern is that the headwinds would be too high, not that you'd have a strong crosswind.
Right. With the winds from the southeast, we kind of thread the needle between the two constraints, actually. So, but the main concern would be more of the headwind concern.
Okay, thank you. And then I had one for Pete. As I understand your reactant load, it's good for 4 attempts through Friday, and I just wonder if there was some circumstance, can you try beyond Friday before the Soyuz mission sort of shuts you down for a while? Can you reload and try Saturday and Sunday, or have you guys reached any decision on that?
I can say that there has not yet been any decision reached, and we're just going to have to evaluate our posture as we approach the middle to end part of the week.
All right, thanks. Stephen, another question?
Steve Seisloff again from Florida Today. A quick one first for Ben. Your S0 truss, is that good to go no matter how long it takes to get Atlantis off the pad?
Right. We have no scrub turnaround requirements for S0 truss or the mobile transporter, so we're good to go.
Okay. And Pete, do y'all have an idea yet of how much gaseous hydrogen escaped on Thursday?
No, I don't know, Steve. But we can try to find out for you then.
Okay. Any other questions? All right, then. Thank you very much.
Good afternoon. From the Kennedy Space Center in Florida, this is Space Shuttle Atlantis Launch Control. And we are at T-minus 2 hours, 13 minutes, 45 seconds, and counting. Countdown for launch of Space Shuttle Atlantis on mission STS-110 is continuing on schedule this afternoon. Launch is scheduled to occur at about 4:40 p.m. Eastern Time, and the launch opportunity window extends for about 5 minutes. The primary objective of shuttle mission STS-110 is to rendezvous and dock with the orbiting International Space Station for the purposes of attaching to the station the S0 truss segment and the mobile transporter. The S0 truss segment is 43 feet long and weighs about 26,000 pounds. And once on orbit, it will be attached to the U.S. laboratory Destiny. This truss will serve as a channel for the electrical power to be generated by the solar arrays to the rest of the station module. And at this time, we have a tape of the astronauts as they are seated for their traditional meal. This was recorded earlier this morning at about 11 o'clock. Mission Specialist 1, Rex Walheim, and Steve Smith. Both of these astronauts will be performing EVAs on this flight. First-time flyer, pilot Steve Frick, and his commander, Mike Bloomfield, preparing for his third flight on the space shuttle. Ellen Ochoa, preparing for her 4th flight, also a mission specialist. And rounding out the team is mission specialists Jerry Ross and Lee Morin, both of them preparing for spacewalks on this mission. Crew members, of course, beginning with Commander Mike Bloomfield. He again is preparing for his 3rd mission. He last flew on STS-97, which was the delivery of the P6 truss segment to the station back in the year 2000. Pilot, first-time flyer in the space shuttle today is Steve Frick. He's been an astronaut since 1996. Rex Walheim, seen standing here, virtually complete in his suiting operations. Stephen Smith, giving his thumbs up, he's ready to fly today. He's preparing for his 4th flight on the space shuttle. Mission specialist Lee Morin, looking forward to his 1st flight. Dr. Morin is a captain in the U.S. Navy. And hidden behind her helmet is Ellen Ochoa. Ellen is a veteran space shuttle flyer. This will be her 4th flight. And finally, our most experienced astronaut, who is preparing for his 7th space shuttle flight, is mission specialist Jerry Ross. And our astronauts, of course, as they depart the crew quarters on the 3rd floor of the Launch Control Center, making their way to an elevator that will take them down to the astrovan that will drive them out to the pad. Charlie Precourt, seen there in the center of the elevator, will be flying our shuttle weather aircraft today and making assessments of our weather, flying in the shuttle training aircraft and T-38 training aircraft. And again, the astronauts having departed their crew quarters, boarding the astrovan. Somewhat windy conditions today. However, it's been determined that the chances of getting off are better than not, so we're sending the astronauts out to the pad, and operations are continuing on schedule to have them enter the vehicle. We will join now, in progress, the crew entering the vehicle. Commander Bloomfield entered the vehicle just about 15 minutes ago, and he was followed by mission specialist Steve Smith, who entered the vehicle shortly after that. And then just moments ago, our pilot, Steve Frick, entered the vehicle. And so therefore we have 3 of the 7 astronauts on board at this time. Next to enter and being strapped in with his flight suit and so forth in the white room is Lee Morin, and he, a mission specialist, will be climbing aboard the vehicle in the next few moments.
OTC CBSE 212.
Yes, sir. Step 571.
That'll be an upper form today.
Copy.
watching again live Ellen Ochoa climbing into the vehicle, and she'll be sitting in the empty seat behind the commander. That's seen in this view of the flight deck.
How many wrecks?
I got you loud and clear, Teresa, thanks.
And good afternoon.
Good afternoon.
And OVCC, I copy MS2 on board.
Thank you, ma'am.
And now with Ellen Ochoa on board, all 7 astronauts have gotten on board Atlantis. And also at this time, the ground launch sequencer computer program has been started. Engineers are beginning to set up the specifics in the launch processing system that the ground launch sequencer will use as its guideline for allowing our countdown to continue smoothly. One of the interesting facts about this particular mission, STS-110, is that as the shuttle continues to be improved, the Atlantis is the first flight to rely exclusively on the latest main engine redesign, a design that more than doubles estimates of engine reliability and safety. All the 3 main engines on Atlantis are Block 2 engines, and that again is the first time that a shuttle has flown with the complete cluster of Block 2 engines. Previously, only a single Block 2 main engine flew on the shuttle back on STS-104 in July of 2001, with the remaining 2 engines being of an earlier design.
And attention all personnel, this is the entity conducting the launch status check. Verify ready to resume count and go for launch. OTC?
OTC, go.
TBC? TBC, go. PTC? PTC, go. LPS? LPS, go. Houston flight?
NTD Houston flight 212.
Verify ready to resume count and go for launch.
Houston flight is go.
Copy. Mila? Mila, go. STM? STM's go. Safety console? Safety consoles, go. SPE?
SD's go.
LRD? LRD, go. SRO? SRO is go. You have range clear to launch. Copy. Yes. And CDR? Atlantis is ready to go. Launch Director NTD? Launch Director. The launch team is ready to proceed at this time. I copy.
Chief Engineer, Launch Director, verify no constraints to launch.
Steering team is go.
Thank you, Charlie. KC Safety Mission Assurance.
9668. KFC SMA is go.
Thank you.
9668.
International Space Station Launch Manager.
Mike, on behalf of the NASA and Boeing Space Station team, we're go for launch.
Okay, Bill, thank you. Range weather.
Weather is no constraints to launch.
Okay, Kathy, thank you. And Ops Manager.
Mike, the mission management team is working. No issues. You have a go to resume the count.
Okay, sir, thank you. Atlantis Launch Director.
Go ahead, Mike.
Okay, Bloomer, looks like we've got a good vehicle for you today. You spent a few extra days in Florida, but it's time for you guys to take a ride, so we wish you luck on the next assembly mission to the International Space Station.
Well, thanks a lot, Mike. Thanks to everybody, your entire team, for all the hard work getting Atlantis ready to go. And a big thanks to the folks who worked over the weekend repairing the hydrogen line so that we were ready to go today. We also want to thank the S0 team that put together the payload that we'll be happy to take into space for them. And finally, we want to give a big thanks to Jeannie Alexander. She's been strapping in shuttle crews now since 1983, and this was her last time, and it was our privilege to be part of her team. So thanks to everybody, and we'll see you back here in about 11 days.
Okay, Bloomer, I appreciate those good words, and I accept them on behalf of the large team that's gotten you ready to fly. And NTD, with that, you're clear to proceed.
I copy, and thank you, sir.
Coming up on the orbiter access arm retraction, that should be happening in the next few seconds. This is the walkway used by the crew to gain entry into and out of the vehicle. It can be returned to position within just a few seconds if necessary.
Atlantis has been, which was scheduled to blast off from the Kennedy Space Center in Florida more or less now, that has now apparently been delayed by 5 minutes, presumably due to high winds or maybe some other difficulty. High winds had been a problem, which it was thought could have delayed that launch, but we'll bring details as we have them. So.
Again, the primary objective of this shuttle mission is to rendezvous and dock with the orbiting International Space Station to deliver the first segment of the 356-foot-long truss. This segment is considered the second most complex station component next to the Destiny Lab, with over 400,000 parts. T-minus 3 minutes, 45 seconds and counting. And a final test of the flight control surfaces is being conducted. This is a program pattern of movements designed to verify the readiness for launch of the engines and the other flight control surfaces. And the aero surfaces and the engines are being gimbaled at this time. Again, this is a final engine check before launch.
TLT, OTC.
OTC, go ahead.
Clear caution warning. Memory, verify no unexpected errors.
Purge of the main engines is complete, and the gaseous
Warning is cleared, no unexpected errors.
The gaseous oxygen vent hood is slowly being retracted away from the top of the external tank.
Atlantis, OTC, close and lock your visors and initiate OT flow.
Inward.
And we have a go for auto sequence start. Atlantis onboard computers have primary control of all the vehicle's critical functions. T-minus 20 seconds and counting.
To the Kennedy Space Center in Florida, because the Space Shuttle Atlantis is now scheduled to blast off from Kennedy Space Center. Let's take you there and listen in.
15 seconds. 12, 11, 10, 9, 8. We have a go for main engine start. 6, 5, 4, 3, 2, 1. We have booster ignition and liftoff of the Space Shuttle Atlantis, setting in place the Keystone to the space station's backbone.
Houston, Atlantis, roll program.
Roger, roll, Atlantis.
Houston's now controlling Atlantis, rolling on course toward the International Space Station. Atlantis already traveling more than 300 miles per hour. Altitude now 2 miles, downrange about 1 mile from the launch pad.
So the launch of the Space Shuttle Atlantis there from the Kennedy Space Center in Florida, taking off on an 11-day mission, which with a payload not only of 7 astronauts, one of whom is in fact going up into space for the 7th time. That is a record. And among the issues, among the items that are being carried aloft there is a truss which will go to the International Space Center and which will support a 1-acre array of solar panels.
T-minus 20 seconds and counting. T-minus 15 seconds. 12, 11, 10, 9, 8. We have a go for main engine start. 6, 5, 4, 3, 2, 1. We have booster ignition and liftoff of the Space Shuttle Atlantis, setting in place the Keystone to the space station's backbone.
Houston, Atlantis, roll program.
Roger, roll, Atlantis.
Houston's now controlling Atlantis, rolling on course toward the International Space Station. Atlantis already traveling more than 300 miles per hour. Altitude now 2 miles, downrange about 1 mile from the launch pad. 3 engines on board Atlantis have throttled back to 2/3 throttle to prepare the spacecraft to pass through the area of maximum air pressure and go supersonic.
Atlantis, Houston, go at throttle up.
Go at throttle up.
3 engines on board, back at full throttle. Atlantis now traveling more than 1,000 miles per hour. 1 minute, 10 seconds since launch. Atlantis has already consumed more than 1 million tons of propellant. Altitude now 12 miles. Speed 1,700 miles per hour. 10 miles downrange from the launch pad. Minute and 45 seconds since launch. Flight controls will be standing by for burnout and jettison of the twin solid rockets. That coming up in just about 10 seconds. Solid rocket booster jettison. Altitude now 30 miles. Speed 3,070 miles per hour. Downrange 40 miles. Atlantis 2 orbital maneuvering system engines firing now. They'll fire for about 1 minute 16 seconds to assist a boost of the main engines for the shuttle as it continues en route to orbit.
Atlantis, Houston, you are 2-engine TAL. Update to your no-com mode boundaries. Press to ATO 10.8. Press to MECO 15.5. Single engine press to MECO 17.9, negative bend 15.9, and you are launched in plane plus 2.5.
Okay, Scorch, copy. We copy all those words.
Those calls indicating that Atlantis could reach a transatlantic landing in Spain if required. All systems go, however, for Atlantis. 3 engines continue to operate at full throttle. Speed now 4,100 miles per hour, altitude 53 miles. Downrange 104 miles from the Kennedy Space Center.
And Shannon, you can see the main engines starting. There's liftoff. A lot of shake and rattle and roll. Here comes the roll program. You can see the sun moving across the windows. You can certainly feel the additional thrust when the engine's throttled back up at about 1.2 Mach. This is where we got to go for throttle up. That was 90 seconds into the flight there. Solid rocket boosters are starting to tail off in their thrust, and the ride's becoming smoother as we get above the denser part of the atmosphere. PC less than 50, watching for the solids to come off. There they go. You can see the smaller rocket motors burning to thrust them away from us. watching the video here, I might tell you that we did see a red service light on BPS at about 3 p.m. local time at the Cape, and about an hour later it was back off. Also, we did get 35 millimeter shots of the external tank. I think I got about 26 or 7 shots in before it went dark.
Thanks a lot for that update, Jerry. We appreciate knowing that, and the video is really good coming down. We're getting just great video.
Super. Glad to hear it. And Shannon, we're about 2 minutes from MECO right now, and you can see that we're just finishing the roll the heads up.
Yeah, we were just talking about that. That was pretty cool.
And Houston, there's MECO, and you can see the lights out the front window as they come off the external tank.
And we noticed that. This is really fantastic video right here.
We have booster ignition and liftoff of the Space Shuttle Atlantis, setting in place the Keystone to the space station's backbone.
Atlantis will be docking with the International Space Station to deliver a 13-meter girder, which will form the foundation of a structure that will eventually be larger than a football pitch. Strong winds had threatened to delay the launch, and NASA had kept the launch time a secret as an anti-terrorist measure.
Begins their 11-day mission. Astronaut Jerry Ross to set a space flight record.
This is Lou Dobbs' Money Line for Monday, April 8th. Here's
Carrying parts of the first railroad to space. We'll have the details next. Stay with us. Look forward to it. The Space Shuttle Atlantis today blasted off from Kennedy Space Center. It's on an 11-day mission, and the shuttle carrying a team of 7 astronauts, including Jerry Ross. He's making a record 7th flight into space. Their mission to install a girder that will serve as a backbone for the International Space Station. It's a 44-foot long structure. In point of fact, it will have railroad tracks on it. And in the future, a rail car will be used to move massive pieces of equipment around the outpost in space. The shuttle was originally scheduled to have taken off last Thursday, but a leak in the hydrogen tank of the shuttle forced NASA to postpone the mission. Security at the launch site, of course, especially tight. 2 small aircraft violated that airspace and were escorted from it by F-15 fighters.
Verspätung ist am späten Abend die US-Raumfähre Atlantis zur internationalen Raumstation ISS aufgebrochen. Der Start hatte sich wegen eines Computerproblems und eines Lecks in der Wasserstoffleitung der Rampe verschoben. Das Zeitfenster für den Start wurde gerade noch eingehalten. An Bord des Shuttles sind 7 Astronauten. Sie sollen bei ihrer Mission ein Metallgerüst an der ISS befestigen, an dem dann später weitere Komponenten angebracht werden.
The This is Mission Control Houston. Again, we are continuing to receive downlink television pictures from on board the Space Shuttle Atlantis as it orbits at about 120 statute miles over the midsection of the United States. This particular orbital pass is taking the shuttle over Southern California and Nevada, the central portion of Utah, Wyoming, and North and South Dakota, and the northeastern portion of Minnesota and the Great Lakes before going out overhead of Canada, one of the International Space Station partner nations. Space Shuttle Atlantis on its way toward a rendezvous with the International Space Station around 11 a.m. Central Time on Wednesday. The first spacewalk to begin installation of the S0 truss structure with the assistance of robotic arm operator Ellen Ochoa and her cohorts aboard the Expedition 4 crew of the International Space Station, Dan Bursch and Carl Wall, scheduled for Thursday morning as the S0 truss structure is lifted out of the shuttle's payload bay and attached to the top portion of the Destiny laboratory module.
This picture from the normal television system on board the shuttle, the analog television system. The crew was working to set up the digital television system, a system flying for the first time on board Atlantis, rather. That system, however, the configuration did not work as expected, so controllers here studying the situation may ask the crew to perform a couple of other steps with it later during the day. This picture, however, live from the flight deck via the normal analog television system aboard Atlantis.
We're on board and looks great. You know, the picture did look really good, and now it's looking kind of marginal, at least for content. Although you're looking much more CJ-like now, Jerry. Very nice.
Commander Mike Bloomfield and pilot Steve Frick have completed a checkout of the shuttle's robotic arm, finding everything in good working order, the arm in good shape. According to the Payload Deploy and Retrieval Systems Officer in Mission Control, the position with responsibility for oversight of robotics activities. This is a live television picture from a camera in Atlantis' payload bay. The arm now will be used for a survey of the S0 truss, the 44-foot long station truss segment housed in the cargo bay of Atlantis, using television cameras attached to the arm. Bloomfield and Frick will take various views of the truss, inspecting its condition in orbit.
Atlantis Houston, for Steve, we've got you live and looking great on the downlink, and I have a partial answer to your question on DTV.
This is a live television view from the flight deck of Atlantis. Pilot Steve Frick in the picture momentarily was Ellen Ochoa also.
I feel like I'm talking right to you. We agree with you that it shouldn't matter what power source you're using, so we don't think that that is the problem, and you are looking fine as well, Jerry. It's not going to work. I give up. You know, the picture did look really good, and now it's looking kind of marginal, at least for content. Although you're looking much more CJ-like now, Jerry. Very nice.
And you're not only a space center in the number of flights that you've taken, but also your time walking in space, and you've got your 8th and 9th spacewalks coming up with this flight. Tell me a little bit about that pace that you're setting, 44 hours in space, and then also, what does it feel like to walk in space?
Well, if you can see the smile on my face, you'll know what it's like to walk in space. It's a tremendous experience. We do have a lot of other fellows in the office right now that are close on my heels in terms of the number of spacewalks as well as the number of hours outside, and I expect that some of them will be passing me up in the near future.
Now, Dr. Ochoa, could you tell me a little bit about what this mission, this flight mission is, its goal is with the space station?
Well, right now on board the space station, we have a working laboratory that Dan and Carl and Yuri are using daily. And what we're trying to do is start the next level. We want to bring up more laboratories that have been built by different countries around the world, start to get more of the international and international space station. And one of the key components to doing that is providing more power. And the way the station is designed, we have a long horizontal truss, and the end of that is where the large solar arrays are going to eventually go. And so our job is to bring up the very first segment of that truss. It's a 43-foot-long segment, right out in the payload bay, right out the window here, and we'll be installing that in just a couple of days.
More than 1 million people took to the streets of London for the funeral procession of Britain's much-loved Queen Mother. CNN's Christian Amanpour is in London with more on Tuesday's Royal Remembrance.
It was the moment of final farewell to empire as they paid their last respects to the woman who symbolized Britain's greatest age. Queen Elizabeth, the Queen Mother's life of public service spanned an entire century, and the best of British pomp and circumstance paid tribute. A gun carriage bore her coffin, atop which lay the crown she wore for the coronation of her husband, King George VI, in 1937, as well as a wreath of white roses from her daughter, Queen Elizabeth II. Behind and on foot, the senior male members of the royal family, led by Prince Philip, her son-in-law, her grandsons, and in a break with tradition, her granddaughter, Princess Anne. The Queen led the rest of the royals inside Westminster Abbey, where prime ministers, politicians, foreign dignitaries, and representatives of 25 foreign royal families made up more than 2,000 mourners.
I will lift up mine eyes unto the hills, from whence cometh my help.
The funeral was marked by the Queen Mother's favorite hymns, Bible readings, and a eulogy to the very human as well as the formal side of a long and eventful life.
The Queen Mother's strength as a person was expressed best through her remarkable dealings with people, her ability to make all human encounters, however fleeting, feel both special and personal.
Outside, the public followed the service by loudspeaker, and when the funeral ended, the Queen and her family escorted the coffin past the tomb of the unknown soldier, where the wreath of roses will be laid, echoing what her mother did in 1923, when she spontaneously placed her wedding bouquet on the tomb. The public lined the route, and some threw flowers as the hearse carrying the Queen Mother's coffin wound slowly to her final resting place. A flyover by the Battle of Britain vintage aircraft, a final tribute to the woman who had done so much to help rally and comfort a country during the darkest hours of World War II. The Queen Mother is now buried in the historic Windsor Castle outside London, reunited half a century later in the family vault with her husband, King George. In 1900, when the Queen Mother was born, the British Empire covered 1/5 of the Earth's surface, and the hundreds of thousands of people who turned up to view her coffin lying in state and her funeral were perhaps saying farewell as much to a proud history as to a beloved national symbol. Christiane Amanpour, CNN, Westminster.
called Rapunzel and asked, "What's the matter?" She said,
"I got a news to you, better bring a ladder."
"You can take the story and turn it around, turn it inside out, turn it upside down." And Gretel got a compass, a compass, a compass. Gretel got a compass to find her way home. She won't be dropping breadcrumbs, breadcrumbs, breadcrumbs. She won't be dropping breadcrumbs. She'll get home on her own.
Good morning, Atlantis. Happy Rendezvous Day with a special good morning to Ellen on this beautiful April 10th.
Thanks very much, Shannon. That was great wake-up music, and I'm sure you played it because it's Jordan's second birthday, and I'm thinking about him and about Wilson, too, and we're ready to go today.
Glad to hear you're ready to go, and yes, we were thinking about Wilson and Jordan on his birthday.
Atlantis, Houston, good config for the burn.
About 1 minute to the engine firing now. The first of 2 engine firings that will raise Atlantis' orbit by more than 115 statute miles to closely match the orbit of the International Space Station and prepare the shuttle for the final phase of rendezvous set to begin later this morning. That final phase set to begin at 8:45 a.m. Central, leading to docking with the station anticipated about 11:06 a.m. Central Time. About 10 seconds now to the start of a 2-minute, 19-second long orbital maneuvering system engine firing for Atlantis, accelerating the shuttle about 145 miles per hour, raising its orbit up to that of the International Space Station. Atlantis engines firing. About 2 minutes left to go in the engine firing. Atlantis orbital high point is increasing as the engines continue to fire. That altitude now 187 statute miles for its apogee. 50 seconds left to go in this engine firing. Atlantis orbital high point now about 230 miles. About 10 seconds left to go in this engine firing.
Atlantis, Houston, great burn, no trim required.
Copy, no trim required.
This live television now of the aft flight deck of Atlantis as astronaut Ellen Ochoa begins setting up laptop computers that operate as navigation aids during the rendezvous and approach to the station. Television view now from the International Space Station.
Targeting your go to burn the onboard.
This a view of Atlantis as it approaches the complex. This view as seen from a camera on the station's Canadarm2 robotic arm. Atlantis at present, according to onboard radar from the shuttle, is about 9 statute miles away from the complex, closing in at a rate of about 5 miles an hour. On board Atlantis, the crew's about 2 minutes away from the first of 4 small course correction engine firings that will be performed to fine-tune its course toward the station. This first course correction engine firing only a 2-second long pulse of the shuttle's steering jets. This view of the truss, courtesy of a camera mounted on the station's Canadarm2 robotic arm, the arm that will be used to lift the truss out of the payload bay and attach it atop the Destiny laboratory.
Houston, Atlantis, you got KU configured for comm.
Copy, thank you.
Atlantis range to the station about 585 feet. Commander Mike Bloomfield will begin flying Atlantis now up from a point where it is directly below the station, closing in as he flies to a point directly in front of the station, aligned with the station's shuttle docking port. As he flies up to that point in front of the station, he'll move in from the current 567-foot distance to a distance of about 310 feet by the time he reaches a point precisely ahead of the shuttle docking port for the station. The 44-foot-long truss segment carried aloft by Atlantis occupies the majority of the shuttle's 60-foot-long payload bay. The truss segment, the second most complex station component to be launched aboard the space shuttle, second only in complexity to the United States Destiny laboratory attached to the station last year.
Atlantis Alpha, y'all do make a pretty sight there. Hey, thanks, Carl. It's good to see you guys. Good to see y'all too.
That ship-to-ship exchange between Flight Engineer Carl Waltz aboard the International Space Station and Commander Mike Bloomfield of Atlantis. This still image, updated every few seconds from video on board Atlantis, showing the station's shuttle docking port as Bloomfield brings Atlantis up in line with the port. Range now just under 300 feet between Atlantis and the station.
And Carl, that's a heck of a robotic arm you got there. We can see the tip elbow camera looking at us and the light on. We're waving.
Okay, I think we can see y'all waving in there too. We have you on 2 screens, and we have sort of a big picture view, and we also have a tight-in shot on the flight deck. So yeah, we got a good view of y'all as you're coming in.
Great. If you zoom in, you can probably see all the cameras in the overhead window. I think there's 3 or 4 of them right now.
Yeah, we sure can.
Atlantis Houston, manual DSAT's complete. Go for docking.
Oh, roger, thank you.
Under 10 feet between Atlantis and the station. Atlantis and the International Space Station, 242 miles above China. This is a view of Atlantis docking port moving in to the station. Atlantis moving in at 1/10 of a mile per hour. Contact reported by Mechanical Systems Officer here in Mission Control. Shuttle's steering jets turned off. It put in free drift as planned.
And Houston, Atlantis, we have captured.
And Atlantis and Alpha Station confirms free drift.
The station's also in free drift as the docking mechanism's springs now dampen out any relative motions between the two spacecraft. Docking occurring at 11:05 a.m. Central. That's the bell being rung aboard the International Space Station by Flight Engineer Dan Bursch, signaling the arrival of the 7 astronauts aboard Atlantis. This is a view from inside the Destiny Laboratory, looking at the hatchway to the shuttle docking port.
Atlantis, Houston, we believe that the gauge might have a bias. We believe you're go to proceed.
Okay, thanks for the great words. We're going to go ahead and open the hatch.
This is Mission Control Houston. We can see a good view of the window into the Space Shuttle Atlantis as Commander Yuri Onofrienko of the Expedition 4 crew on the space station prepares to welcome the oncoming Commander Mike Bloomfield and his crew of 7. The STS-110 crew of Atlantis, led by Mike Bloomfield, has begun filing into the International Space Station, shaking hands and receiving warm greetings from the Expedition 4 crew that has been on board the International Space Station alone for the last 117 days. This downlink coming to us from on board the Destiny Laboratory of the International Space Station as Ellen Ochoa continues with those transfer operations in addition to transferring the protein crystal growth experiment. The crew members also, among their first items of transfer, are going to be the 3 spacesuits that Atlantis is bringing up to support the 4 planned spacewalk, as well as reconfiguration of the 1 spacesuit that's already aboard for Rex Walheim. 3 spacesuits from Atlantis will be used by Lee Moran, Jerry Ross, and Steve Smith. Rex Walheim and Steve Smith scheduled to make the first spacewalk of the mission tomorrow for the installation of the S0 truss structure. On your left, we can see Mission Specialist Ellen Ochoa. To her left is Lee Moran, one of the spacewalkers, along with Jerry Ross to his left. In the foreground, on the right, is Dan Bursch, Expedition 4 crew member.
2 Tage nach dem Start hat die amerikanische Raumfähre Atlantis an der internationalen Raumstation ISS angelegt. Das Andockmanöver fand 385 Kilometer über China statt. Schon am Donnerstag sollen ein 13 Meter langes Metallgerüst montiert, Strom- und Datenleitungen gelegt werden und schließlich ein Gerüst entstehen, das die Solarzellen für die Energieversorgung der ISS aufnimmt. Weggerollt. Auch Piloten sollten immer die Handbremse ziehen, bevor sie in den Feierabend gehen. Genau das hat offenbar der Kapitän einer Boeing 767 auf dem Flughafen von Los Angeles nicht getan. Die leere Maschine der American Airlines rollte quer durch den Zaun auf die nächste Straße. Verletzt wurde glücklicherweise niemand.
Raumstation ISS festgemacht. Die Besatzung soll das Weltraumlabor Destiny in den kommenden 7 Tagen ausbauen. Sie muss die Station dazu 4-mal verlassen.
Die Raumfähre Atlantis hat erfolgreich an der internationalen Raumstation ISS angedockt. Die Experten im Kontrollzentrum in Houston, Texas, sprachen von einem perfekten Manöver. Die Astronauten werden in den kommenden 7 Tagen das Forschungslabor Destiny weiter ausbauen. An Bord ist ein 680 Millionen Euro teures Bauteil, an dem die Solarzellen befestigt werden. Insgesamt sind 4 Ausflüge der Astronauten in den Weltraum geplant.
Atlantis ist an der internationalen Raumstation ISS angedockt. Damit erhalten die 3 Männer an Bord der ISS den ersten Besuch seit 117 Tagen. Die Besatzung der Atlantis hat den Auftrag, die Raumstation weiter auszubauen. Bei mehreren Weltraumspaziergängen soll unter anderem ein 12 Tonnen schwerer Träger angebracht werden.
Space Shuttle Atlantis today docked with the space station Alpha 240 miles above China. The 7 crew members aboard Atlantis, along with the Alpha crew, preparing to resume construction work on the station for the first time in nearly a year. Tomorrow, the astronauts are scheduled to make the first of 4 spacewalks. The combined crew of 10 astronauts will spend a week together in joint operations. Those operations to include the installation of a rail system. Now, that rail system is designed to ultimately transport the station's robotic arm, complete with rail car. A short time ago, NASA told us the mission so far is, quote unquote, going great.
Weltraummission. Die US-Raumfähre Atlantis hat problemlos an der internationalen Raumstation ISS angedockt. Die Raumfähre musste sofort entladen werden, weil die Zeit angesichts der geplanten umfangreichen Bauarbeiten an der ISS eng bemessen ist. Die Astronauten sollen ein neues Gerüst an der 17 Stockwerke hohen Station montieren. An ihm sollen Sonnensegel, Hitzeschilder und Generatoren für künftige Labors angebracht werden.
This now a videotape.
We're ready.
This is a videotape being played back from onboard the Shuttle Atlantis of today's docking. Docking occurring at 11:05 a.m. Central Time after a flawless rendezvous and approach to the station by the shuttle. Docking occurred as the 2 spacecraft flew 242 miles above central China. The shuttle's docking mechanism at the lower portion of the screen, the station docking port at the top portion of the screen.
Okay, copy. 3.5, we'll put that in work.
With us today to recap the events on orbit is Jeff Hanley, the lead shuttle flight director for STS-110. Jeff?
Thanks, Ron. I'm glad to be here to give you just a few words of status before I answer some questions about what our day's been like. And in fact, the last couple of days, I'll give you a couple of items here. We started the day with the shuttle in a fairly low orbit. As you may recall, we launched at the end of the window on launch day, and the window that we had defined for being in the same plane with the ISS at the time of launch. And so we've kept the shuttle very low in its orbit so that it could catch up. That's because when we launch late, the target actually goes out in front of the shuttle just a little bit, and that was enough to cause us to have to actually stay low and lap the station one time to catch up with it here on flight day 3. The day started with the shuttle in 122 by 84 nautical mile orbit. We were closing on the station at that point at about 1,000 nautical miles in orbit. As I said, from launch day, we were making up almost 407 degrees of phase angle. We did our first burn of the day, which was a fairly large burn, 270 foot per second, that we using both OMS engines. That raised our orbit to 211 by 115 nautical miles. That was quite a significant raise in our orbit. We tracked out the dispersions that we'd seen, and then did a orbit fairly soon, or another raising burn fairly soon after that to set us up for the rendezvous and put us into a orbit of 211 by 199. We finally caught up with the ISS in a fairly standard rendezvous sequence from that point on, and are currently in docked to the station in an orbit of 211 by 204. As you saw, the crew flawlessly flew approach and docking. It was picture perfect, and met up with the station about 19:30 mission elapsed time. We had only a couple of minor problems in the last couple of days, mainly a couple of jets that failed, at least one failed off on us when we tried to fire it yesterday. And another jet up in the forward end of the shuttle is what we call a low performer. So we were able to actually put that at the bottom of the list of the ones that we'll try to fire. It's still we consider it still a usable jet, but slightly low in its performance. Those are really the only significant issues that we had, and were not in fact issues for the rendezvous and docking. The redundancy of the shuttle is such that they were basically non-players in performing a successful docking. The team is over right now getting set up to not only accept the shuttle crew on the station, but get into some dry run activities to prepare us for tomorrow. As you recall from our talks pre-mission, we'll be doing a dry run of the station, what we call the big arm profile for taking S0 out of the payload bay. We'll go through all the motions with that arm, both in the 6-joint and 7-joint modes that we've defined. And Ellen and Dan both will be doing that activity this afternoon. The EVA team on board will be moving a lot of EVA gear over from the shuttle to the station, configuring tools and the joint airlock for the EVA activities to start about midday tomorrow. With that, I'll be happy to take your questions.
Okay, we'll start here in Houston, then go down to the Cape and other centers, and we'll start with Mark Carreau.
Thank you, Mark Carreau from the Houston Chronicle. Could you just go over, summarize what the game plan would be if you ran into a problem with the arm during the install of the truss?
Okay. We have, as I think we described the pre-mission, we have a new set of software for the arm to be able to run it in a 6-joint mode. And this is because, as you know, we have 2 strings, a primary and redundant string of the station arm. That's when we say string, that's basically totally separate avionics boxes and communications paths between them that operate the joints of the arm. On one of those two strings, we've had a problem with the brake releasing on the wrist roll joint. That's just like with your arm, it's the joint that would allow the end of the arm to rotate about its axis. We have got this new set of software that allows us to keep that joint fixed, and we can swap that over to the new software and utilize the string of the arm that has the degraded joint on it fairly quickly. I'd say within less than half an hour would be my estimation. It's a fairly simple process of just moving some files, executable files, on a hard drive in one of the station computers, and then basically rebooting the arm to now accept that new software. So that's exactly what we would do in that case tomorrow if we ended up facing a problem with the string that is full up with 7 joints.
Okay, thank you. And I just wondered if the checkout of the spacesuits, the shuttle arm, any of that raised any flags that would affect the spacewalk plans throughout the flight?
None whatsoever. The 3 suits checked out just fine. They're the jet packs, the safers we call them, that we use on the back of the suits for contingency purposes. Those checked out just fine. And the shuttle arm also was flawless yesterday.
Okay, let's go down to the Kennedy Space Center for questions.
This is Steve Steislaw from Florida today. I have just a couple, I guess, housekeeping questions. And the first one is, do you know yet how the going in the late launch window affected your propellant load? Do you know yet if you're going to be able to make the full laps at the end of the...
We knew we'd be challenged on propellant because of the late launch, and in fact, when we got around to doing our critical burns today, we used just about every ounce of ohms propellant that we had budgeted. There's a considerable amount of propellant that we carry in the back end of the shuttle for ballasting purposes in the event that we had to return S0 to Earth. So there's a lot of propellant in the ohms pods that we can't use until we hand S0 to the station. So we're well on the way to be able to do that and to free up that propellant now for other purposes, such as mated attitude control, the reboost of the station, and attitude maneuvers to perform things like water dumps. So we've been working hard on that plan in anticipation of that propellant being freed up. We started the day today projecting a slight positive margin in the aft of about a couple hundred pounds of propellant, and expecting to be slightly negative in the forward RCS. And as things turned out today and the way the rendezvous played out, we actually got a little better in the forward, and we used more than we expected in the aft. So we're right about even where we wanted to be. We're not running significantly negative anywhere in terms of propellant, and we feel like it'll be fairly straightforward for us to actually make up some margin by consolidating perhaps some mated attitude maneuvers later in the flight.
Thanks. And when tomorrow will you wipe your brow and feel like you've been relieved? Feel like you're relieved that S0 is comfortable?
For me, it'll be at S0 activation when the power comes on S0, and which basically says that the clock that we have ticking on us tomorrow is stopped. There are a couple of different ways we can get there. We're all going to work toward and hope for having a nominal EVA1, which will install the nominal cable trays on the side of the lab and plug them into S0, and we'll be able to power up by that means. If for some reason Murphy gets involved in our day tomorrow, then we have some backup cables, a couple of which are already plugged in and ready to go, where we can plug those into S0 and power up its heaters and make it thermally safe. So either method would be fine with me as long as we get the element powered up and thermally safe tomorrow, toward the end of the EVA.
Thanks. And I just have one quick refresher question. Which of the spacecraft is in charge now? Is the station or Atlantis?
Well, I think you mean in terms of the assembly activity, and the assembly activity will be conducted out of Station Alpha from the Joint Airlock Quest, and the operations here on the ground will be conducted out of the Blue Flight Control Room under the direction of Bob Castle.
This is Marcia Dunn of the Associated Press. I know it's only 2 days into the flight, but do you have a handle on whether you would be able to add an extra day to the docked activities if you needed it?
Right now, we're certainly hoping to have a couple of days of consumables margin available to us. We'll certainly feel a lot better after we get past these first couple of EVAs in terms of whether or not we'll actually need them. But actually, this flight, we've been very blessed with having adequate, and if not generous, margin in most of the areas. Prop was one of those until we launched late in the window. But we're sitting pretty well for possibly a couple of extension days in capability if we need them.
And thank you. And as the shuttle was closing in on the station, I think I heard Carl Walsh say that he was getting a good picture of the flight deck.
Yes.
And did I hear correctly? And did the station crew actually observe Commander Bloomfield steering in the shuttle?
Well, what they were seeing was the shuttle crew through the overhead windows of the shuttle. As the shuttle got closer, station had fired up its robotic arm TV cameras. And Carl, I think, described he was using one of the cameras for sort of an overview shot of the approaching shuttle, and another for a tight shot on the windows. And he was able to see several of the shuttle crew members waving and taking pictures out the window. And there was actually one point where I overheard Steve Smith and Dan Bursch exchange hellos. They're good friends here on the ground.
Bill Horowitz, CBS. To follow on Marcia's question, when you say a couple of days of contingency, do you mean you're including shuttle post-undocking contingency? In other words, you're not really bookkeeping 2 extra dock days, are you?
No, we right now at this point believe we have the margins that could actually support 2 extra dock days, or very close to that. As I said, that's quite unusual as assembly missions typically go, but that's what we've got. We were very blessed with a very good cryogenic load for oxygen and hydrogen. Actually, during the scrub prior to Monday's launch, over the weekend, the Cape topped off the cryogenic tanks on the shuttle so that we would launch with basically full tanks. And right now we're sitting at right about 1 day and 23 hours of electrical power capability beyond the nominal end of mission and the 2 systems and weather days that we bookkeep. So in essence, consumables-wise, we call it an 11 plus 2 plus 2. We're very close to having a docked mission extension capability of plus 2 days.
Jeff, I can't remember, you told us this before flight, but when would you anticipate making the decision to extend a day? I just can't remember when you said that milestone comes.
Well, you know, those 2 extension days are for unknowns and contingencies. It's very possible that if this docked mission goes pretty much by the plan, that we will undock on the scheduled day. There are other concerns that will weigh into the decision, such as landing weather, the status of the vehicle, and so forth. I wouldn't expect such decisions to really be made until the latter couple days of the docked mission. We'll probably hold our options open until then. We're certainly going to be working to build margin, continue to build margin and consolidate attitude maneuvers, for example, conserve on use of oxygen and hydrogen, cryogenics, and so forth. Until we're well past that point where we're confident that S0 is in good shape to accept the next assembly flight, STS-111.
Thanks. And to follow on Steve's questions, I didn't hear you answer anyway. Do you expect them to have the prop for a full fly around?
Right now, we believe we will have the prop for a full fly around. Certainly, if we are successful also in possibly eliminating one of the For example, one of the dump periods that we had book kept, where we have the shuttle actually maneuver the stack to a dump attitude and then back. If we are able to eliminate one of those periods, then we will actually save a considerable amount of propellant doing that. That's quite expensive, about 150 pounds of propellant to do a dump from the shuttle waste nozzle.
Thanks. Two more quick ones from me. One, the magnitude of the burns today to raise your orbit. I was confused as to whether that was strictly an issue with launching late in the window, or if it was the phase angle that you guys had on launch day, or was it some combination of those two?
It was a combination. We had to stay low in order to make up the phase angle that we inherited by launching at the end of the window. So we didn't have the typical orbit raising burns on flight day 1 or flight day 2 that we normally see in a flight like this if we had launched on time. We saved all that. Usually we would have kind of staged ourselves up over the course of 2 or 3 days. Instead, in this case, after OMS 2, we just stayed pretty much where we were in terms of orbital altitude until this morning. The little burn that we did yesterday was very small and did not affect the orbit appreciably.
Thanks. And the last one for me, I know you guys aren't known for being demonstrably emotional or excited at these things, but you spent a lot of time working on this flight. You're on the eve of, now that you're docked, you're on the eve of actually getting S0 installed. I was just wondering, I don't know, what the mood's like in there. Is it anticipation, excitement, or what you can tell us as you are poised to go off and finally do this thing you've been training so long for?
There's a fairly high amount of anticipation. Looking forward to tomorrow. We feel good about the plan we've put together. We feel good about the team that we've got both in orbit and on the ground to do the job. I'd say we're have high anticipation, looking forward to it. We're very almost elated, if you could say, about the results of today and the mission so far. Really, the Atlantis has been very good to us. Hardly any problems with the spacecraft. Dan and Carl are excited to see the guys and get to work with them. And we're just, I think, very much anticipating a very successful mission. We'll see if that bears out to be true.
This is Steve Seislov again from Florida Today. I just have a quick one following on the questions about the two dock days extension. If you went everything on schedule, would you have any get-ahead tasks that you could take care of that would fill those 2 days or even one of those days?
I don't know of a laundry list anybody's put together of things that we could fill those 2 days with. Those 2 days are specifically intended to deal with problems and unknowns that crop up with the installation of S0, configuration of the mobile transporter, rewiring of the station arm. We have several challenging things yet ahead of us, and so I don't think you'll see us bookkeeping extra tasks, if you will, for those extension days until we can kind of let our hair down and sigh a little bit of relief that we've got the major objectives behind us.
Okay, that's it down at the Cape. We're back here for any follow-ups. Mark?
Mark Harrow from the Houston Chronicle. I just wondered, in light of what you've said so far, is there any urgency about starting early tomorrow on the spacewalk, or do you really kind of have the cushion and the pace that you want to just go ahead as you plan?
We really don't have the luxury of starting early tomorrow. I think what we're going to see is that the pacing item will be the robotics in the morning. Ellen is going to be getting right at the robotics activities about an hour after wake-up. And that there are several points within the robotics profile that we are trying to synchronize the preparation for the EVA with. We don't want to send the crew outside too early, because if we send them out too early, if we get them suited up too early, we're starting to burn the consumables in the suit, primarily the carbon dioxide removal capability of the suit. So we want to keep that out in front of us, and therefore it's tightly choreographed with the robotics. So we're anticipating that starting the EVA early won't be in the cards. Unless the robotics runs ahead,